So what does it mean for a number to be raised to a negative exponent? Like, let's say a to the negative m. What is this even supposed to mean? How is it defined? Well, let's look at some of the reasoning behind that. And in order to understand the reasoning, we first must look at the positive exponents. So let's say we have a to some number m, right? By definition, this is going to be equal to a times dot 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 times a m times. A is going to multiply by itself m times. So let's say we have, or let's consider the terms a to the fourth, a to the third. Actually, I'll write this in ascending order. So let's say we have a to the first, or this is a to the first, this is a squared, a cubed, and a to the fourth. So in order to get to one term to the next, when we're increasing the exponent, what's happening? Well, we're multiplying by a times a times a, right? A to the second is just a times a, whereas a to the first, a squared, is going to equal to this, whereas a to the first is just going to be equal to a. You can see how these two terms just differ because we're just multiplying by a. This is the definition of an exponent, by the way. So you can see that between these terms, we're just multiplying by a. So what if we go backwards? Well, you can see that then we're dividing by a, right? We are dividing by a, or this is also the same as multiplying by 1 over a, because dividing by a number is the same as multiplying by its reciprocal. So this is also equal to multiply by 1 over a multiplied by 1 over a. So this is what happens when we go backwards. So what if we wanted to know what a to the 0 is? What would this be equal to? Well, a to the 0, or any number to the 0, is defined as 1, right? But why does this happen? Well, this happens because when you divide, because this happens because of the pattern. You can see how we're just dividing by a over here. So let's continue dividing by a. So what's a to the 1 divided by a? Or a over a. This is the same as 1. So that's why if we divide by a again, we're going to get that a to the 0 is equal to 1. And the same thing with the negative exponents as well. Let's say we have a to the 0, a to the 1. To go from a to the 1 to a to the 0, we're dividing by a. And we got this pattern from up here, or sorry, not dividing by 1 over a, we're multiplying by 1 over a. So what happens if you wanted to find a to the negative 1? Well, let's just divide, it wouldn't make sense for the pattern to suddenly break, right? I think we should continue the pattern because math is all about patterns. So what if we divide by a again? Well, this is the same. Well, we just said a to the 0 is just 1. So what's 1 divided by a? Well, 1 over a. So this is equal to 1 over a. And what about a to the negative 2? Let's divide by a again. I'm going to get that this is equal to 1 over, well, if you think about this is the same. A to the negative 1 is 1 over a. And dividing by a again, or multiplying by its reciprocal, is the same as 1 over a squared. So this is equal to 1 over a squared. And then we can just continue the pattern on. And we can just say that generally, I'm going to write some dots. So for a to the negative m, generally, this is going to be the same as 1 over a to the m. And this intuition makes sense because of the pattern that we see in the positive exponents. So that's why a to the 0 is defined as 1 and a to the negative m is defined as 1 over a to the m. So I hope this video was of value to you, and so if you like this concise no BS way of teaching, then please consider supporting the channel. Regardless, thank you so much for your time and good luck in your studies.